Again. All right, everyone. We are now recording, and for anybody that doesn't know, I upload these to YouTube to the channel, somewhere in one of the repos, a link to that channel, so you can find it later.
And then here's the agenda and meeting notes link in the chat that I just put for folks to add their names if they wish.
All right, so the recording has started. Do you want to jump in, Santiago? We're going to start with the presentation on In-Toto and TUF.
Okay, just a second. I added my name. Yes. So here's where I awkwardly try to present my entire screen, and we find out whether it works.
We spent a while in the last meeting with David trying to get this working. So, hey.
Okay. So, no. There you go. Do you guys see my presentation?
Yes.
Okay, great. So today I wanted to talk mostly about In-Toto and some of the driving principles behind In-Toto and TUF. And I also wanted to cover some of the future work of In-Toto, to say it somehow, and how it can fit the broader goals of the OpenSSF. To be a little bit more explicit, my goal is to spark a conversation, pretty much to start talking about how we can use these principles that gave birth to In-Toto to answer some of the questions that we are having in the developer identity working group here at the OpenSSF. So to do that, I want to show connection between software supply chains and developer identities, and how solving one is only part of the equation, but solving both is what I think is the future of secure software development pipelines. And to do this, I am going to propose a couple of ways forward. Again, this is only to spark conversation, so I am really hoping to show ideas that are new, that are somehow interesting, and that can probably set some ground for the future work we're going to do here at the OpenSSF. To do this, I'm going to pretty much try to cover all of the bases. I want to talk about how software is made and how it's hacked. I also want to show, and I think this is something that I've been running into when I talk to a lot of the communities out there, some of the guiding principles. This is a little bit on the academic side of things, but why In-Toto is like it is. And to do that, I'm going to talk about artifact flow integrity, artifact authentication, and supply chain layout integrity. Then I'm going to show how this come to life in In-Toto as a framework that you can use today. But then what I think is the most interesting part of this is what I want to mention beyond the chain, how you can use In-Toto to, for example, authenticate actors in the chain, and how you can use In-Toto to ensure best practices, something similar to what the CAI badging process works today. So without losing any more time, I just, and I apologize if for the people here that have been to like KubeCon or CDCon or any of those like Linux Foundation sponsored events, because probably this will be repetitive for you, but I really want to cover exactly what's the problem space that In-Toto set off to answer, and how we eventually came to where we are right now. So here is a stylized software supply chain, a very basic GitHub generation type of software supply chain. You expect some developers to put in some code and probably Git, perhaps GitHub. If you're feeling fancy, you're probably running some tests on every single commit or pull request to ensure that everything is still compiles and it's passing all the tests. If you have a lot of resources and it's a big build, you probably have a build farm somewhere or some developer infrastructure that can actually build. And eventually you package everything together and distribute it to the users. Now, In-Toto is trying to answer the question of security. So you wouldn't be surprised if I told you that hackers can actually break into all of the steps in the supply chain that I spoke about. And this is actually not an academic problem. We have seen cases such as the Free Software Foundation software repository being hacked. You have seen cases of multiple different source code repositories hacked to try to introduce backdoors, or to, for example, in the case of the Juniper firewalls, to introduce a small change in the pseudo-random number generator in such a way that anybody who knew this change existed, they were able to decrypt every single conversation that was being used by the Juniper firewall VPN ScreenOS operating system. Of course, back when this happened, it was a big compromise, and it pretty much outlines how a little small change in the version control system by an authenticated attacker can bring down the whole thing. There's other cases like what I brought, Linux kernel compromise, ProFTPD, and this is just for the version control system. There's cases of compiler backdoors. There's, of course, the Ken Thompson hack, which pretty much sparked the whole conversation around compiler backdoors. But a more realistic one is the iOS Xcode Ghost attack. For those of you that are not familiar with this, it was a hacker that started publishing a version of Xcode Ghost that introduced a backdoor into all the compiled iOS apps that were done with this toolchain. And interestingly enough, very popular applications actually ended up having this backdoor. One of them that I can remember from the top of my head was Angry Birds, which I assume that many people here at least heard of or know somebody that's using Angry Birds. So this is the blast radius of the compromise. Somebody putting a small change somewhere in the pipeline brings down the whole system. And of course, this is not pointing fingers. There's been many different instances on different parts of the chain. And like in the build, you can have compromises in the packaging infrastructure. There's one that I like a lot, how somebody built a botnet of 800 or so hosts in less than 20 hours just because they published a compromised version of Linux Mint in the Linux Mint website. There's other cases like Kingslayer. There's the PHPMyAdmin corrupted copy on a Korean mirror server. I like this example, for example, because it allows us to see how a clever attacker can target a particular population. In this case, it was a South Korean mirror, which in turn means that maybe a political situation was going on there. Maybe this particular population was of interest to the attacker. People point out maybe North Korea did it. We don't know, but it's cases like this. There's even cases of compliance. One of them is Linux kernel being published without being tested. It can happen to anybody. Another more interesting case is Windows published an update that essentially bricked your machine. And originally, everybody thought like, oh, Windows got hacked, and the hacker just like created havoc in the whole Windows ecosystem. Then Windows very diligently went and did an internal audit, and they found out that the person that was supposed to check that the update wasn't breaking the machines, just had a slip. And that's a question of compliance, how a small human error, a small deviation from the process can result, again, in uncountable damage to the users. So here's where I want to stop. I use this slide generally to showcase how something that looks very simple, something that one would expect that many of the people here would say, well, I can set this up in a couple of days, but real software in the industry is actually way more convoluted and way easier to protect. But here we have a supply chain that is just essentially 4 steps of 3 that if they get compromised, we have a complete subversion of the whole system. So how can we fix this? Well, there's many good point solutions. There's things such as Git signing, there's push certificates, there's TPMs and HSMs for builds, there's verifiable compilers, there's reproducible builds in place. There's things such as DLS, GPG, and TOF to sign your releases. You can add their notary and many last mile solutions to protect your infrastructure. But the question is how we fix this just by putting all of these little elements in place. And I think the answer is, well, how do we know these things are in place? How do we know that even if commit signing was in place, it was actually followed the way that it should, and that the person that's supposed to build out of the latest Git tag actually checked that the Git commits were signed, and they were signed by the right people. And the same goes for the testing infrastructure, and the same goes for the packaging infrastructure. So here's where essentially, as academics, we step out, and we try to understand what are the principles, the security principles that are missing. And this is what drove Intodo, and this is what I wanted to underline here to have a conversation about how this could apply to new challenges that we're facing. And these principles are three. The first one is called supply chain integrity, which is a supply chain structure, supply chain graph, not modified by adding elements or not. I'm going to talk a little bit more about it later. The other one is artifact flow integrity, which means have the artifacts as they were passed through the chain not modified in the transition. And finally, step authentication, which is the person that's supposed to perform a step, the right person to perform that step. So to put it a little bit more clearly, supply chain integrity means we know that there's a version control system, there's a build server, and there's Travis CI running on this, and we have a packaging step that's supposed to produce a Debian package. Now, this means that we should be able to tell if steps were flipped around, if somehow packaging of the sources was done before building, which I know it's a little bit weird, but it is wrong. Another thing is, well, what if somebody just disabled tests? We want to be able to say, well, that's also wrong. We shouldn't trust a package. This is exactly the type of things that caused the Windows, not malicious, but faulty update. And finally, we want to know, and by the way, parentheses, I don't want to call out Gremlin as something bad. I just found that the logo was very nice. We want to know that there's nothing else added. In this case, if somebody added some sort of special tool to make the tests pass, we want to say, well, we don't trust that either, because it's doing something that we don't know if it will have an effect in the chain. So that is what we mean when we say software supply chain integrity. It means that the chain is integral. It hasn't been modified. The second principle is artifact flow integrity, which means, well, we know that the version control system will produce sources. We know that the build system will take sources and produce probably a binary or some sort of like intermediate representation of bytecode. And we know that the packaging will take in the result of the build and we'll put it on a Debian package. So we want to make sure that there's no tampering as the sources go into the build and as the products of the build make it into the package. That is what we call artifact flow integrity. So that somebody broke into our version control system and modified the tag, we want to be able to say, hey, I don't trust the result of this build because it didn't take the right sources in. There's a disagreement as things made it through the chain of custody, to say it somehow. That is artifact flow integrity. And finally, step authentication. Many of you may have guessed, it's like, well, all of this was done, the flow was proper, but was it done by the right person? Was Bob, the not builder, but version control systems person, producing the right sources or tags? And is Carol, the builder, taking in the right sources? And is she the one that's doing the builds? And finally, is Erin the one that's packaging, or is it somebody else that we don't trust? And we want to make sure that this is the case because we want to make sure that the person who's performing each transformation in the chain is trusted. So with these three principles, we can build something like Intodo. Again, software supply chain integrity, artifact flow integrity, and step authentication. And we want to build a system that, using these three principles, can answer the following questions. One of them is, are the steps in the software supply chain verifiably defined? Do we know that they are the right ones? Supply chain integrity. Are the steps actually performed by somebody who we trust, which is a step authentication? And finally, with those two answers to the questions, we can guarantee that everything happens according to the definition and nothing else, which also answers the question of artifact flow integrity. So how do we do this in the Intodo world? In Intodo, we have basically a file called a layout that describes essentially the steps that need to happen, supply chain integrity, It also assigns functionaries, as we call them, which are the individuals or machines that are supposed to take care of each individual step. It also lets them register materials and products, which is what are they supposed to consume and produce. And it lets you, using a small domain-specific language, say what is supposed to how is it supposed to flow, to answer the artifact flow integrity question, which is, again, we want to make sure that the sources that Bob tagged were the ones that Carl and Dave used to run the test and to build the binary. And we also want to make sure that the binary that Carl produced is the one that Aaron is actually putting into the Debian package. Now, this describes what is the expected result of the supply chain. But there is a question of, is this what actually happened? Oh, sorry, I forgot. You also need to have a signature over this so you know that this comes from the right person. But to answer the question of is what happened the thing that is supposed to happen, we will have another piece of information called in total links, which are basically rubber stamps over the operations that were done, that they will register who did it, how did they do it, what did they take as materials, and what did they produce as products. All of this rubber stamped information can then be shipped as a final product along with a policy for the end user to verify. The end user can basically go back and say, well, I know that there needs to be this 4 steps. Is there enough evidence that these 4 steps took place? And can I actually follow the cryptographic paper trail from my package all the way into the version control system? And there's no disagreement between all of the members in this chain of custody. In total basically does it in a way that you provide a layout and a public key, and it takes it from there. Now, what I find more interesting in Toto's done today is that these principles can actually apply to answer questions that are beyond just supply chain security, but essentially automating processes and describing trust relationships between different parties in an ecosystem. So 2 examples that I wanted to bring forward was, one of them is automatically onboarding trust in an ecosystem. And the second one is verifiably checking the best practices. So the first one, to give an example, I've recently moved to the Midwest. So I found out that I do need to drive around, especially if I want to buy a guitar amplifier. I need to drive far from home. So I went to the DMV website and I tried to figure out how do I exactly get a driver's license, my identification that I am allowed to use the infrastructure that's called the road. And actually, I found that it was very complicated. So I moved to an example that's a little simpler, how to get a parking permit in London. So this process is very similar to the supply chain. I need to go perform an operation. I need to prove that it's me. I go to Ringo and register for a permit. Then I need to go and complete an application form somewhere else. And finally, I can go purchase my permit somewhere else. All of these 3 things need to be done with different custodians, and they gave me essentially what's an artifact. It's a proof that I can use in the next step to perform the next operation. So to bring this example a little back down to the software supply chain security world and the total speak, well, we have the supply chain in which we basically had Bob produce some elements that were needed by Carol to perform her operation, and Carol produced something that Aaron needs. So imagine that we can use something like this to automatically onboard, say, Maya into the kernel.org ecosystem by making sure that Maya is doing 2 things. One of them is she's acknowledged by Linus and Greg and Junio. So they sign her key saying, well, I saw her passport. I know that 2 weeks ago we heard that was somewhat hard to do, but imagine that it happens. Imagine that we can do this. These 3 people will sign her key and say, well, I recognize her as a physical entity. But also, we can do other interesting operations, such as, well, Maya can take the code of conduct and read it and create an attestation that say, I, Maya, hereby declare to follow the code of conduct of kernel.org. And finally, we could have an operator saying, well, now that I have these two pieces, I can create a small artifact that can be used to show that Maya has done all of the onboarding process, and therefore she's trusted to use the infrastructure within the kernel.org community. So in a sense, what I'm bringing forward is how can you actually use software supply chain principles, artifact flow integrity, step authentication, and supply chain integrity to make sure that somebody is following all of the required steps to be trusted, to be a trusted member of certain communities. And we can use this to perform very powerful operations such as cross-organizational trust, such as checking that somebody's auditably creating attestations of, for example, DCO, or, well, you name it. Now, the other example that I wanted to bring forward is how can we verifiably check best practices. Many of you may be familiar here about the CII badging program, which is it's something that I actually love, and Toto is on its way to get to gold, which is I, as somebody who's producing open source, I want to check what are the best practices for the development of my application, and I want to ensure that I'm following them, so my application is more secure, and thus users can trust it when they're making decisions on what types of things they're using. So CII may tell you things such as, well, you need to have a SSL distribution of your sources, so it's not easy to man in the middle the connection when somebody's downloading your product. They may also tell you, well, you need to also statically analyze your application to make sure that the way that you're writing code is not obviously vulnerable. So you can use an application like kubesec to analyze some of your Kubernetes deployment YAMLs. And they may also tell you, hey, you need to run continuous testing in your sources to make sure that every single change that you're making follows the code quality that you expect. So say that Maya is actually writing a new Debian package, and she wants to show that the best practices are being followed. The way it works today, she says, I did it, I swear. And in the best of cases, the best practices infrastructure will run an automatic check, and hopefully constantly will do it, but it has no notion of where has this actually been followed in the latest artifact, or has this actually been followed on the artifact that's intended. So we can use the same supply chain security principles to build something that can allow us to create the next generation CII best practices effort. Say that we, for example, have the CII created a CII vetted layout that says, well, we actually expect you to do all of these things. And then Maya can go and say, like, well, I'm going to do all of these things. I'm going to make sure that this SSL is there. I'm going to talk to Let's Encrypt and get a certificate. I'm going to run kubesec.io on my application to get to make sure that things are right. And I'm going to constantly run Travis CI over them. If we do this way, we can have some providers creating links that basically said, oh, well, I'm Let's Encrypt, and I know that Maya requested a certificate for her application. And I am kubesec, and I know that Maya ran a static analyzer on her code. And I am Travis, and here's the latest attestation of the result of the run. So they link back. We can use the same benefits on the CII system that the software supply chain security community, I would say, are trying to get, which are supply chain integrity, ensure that everything was done, artifact flow integrity, ensure that they were done on the right artifact, and the step authentication, that these checks were actually done by the right people. So supply chain integrity, we have a CII vetted layout that tells you exactly what needs to happen. Artifact flow integrity, we know that the artifact being analyzed and being checked by this individual efforts were done by the right on the right artifact. And finally, step authentication. We know that Let's Encrypt is the one that's giving you the attestation, and not some random colluding party that's pretending to do the thing but not really doing it. And to wrap up, Entoto is used today to ensure software supply chain security. Its driving principles can help understand supply chain security threats, And it's all about the process. So you can use it in many other ecosystems that may be in need to answer questions such as, was everything done? Was it done by the right people? And is there a flow of information that's integral? And with that, I think I want to open the floor for discussion.
Thank you. That answers a bunch of the questions and vague areas I've had in my head around the different types of attestations and how they can flow through. I have one kind of question. This all kind of seems to hinge on a PKI still. And I know Entoto supports PGP and a bunch of other types of signatures. Is there any specific PKI you see people using? Like if people are producing these link files, but all using different types of keys and signing strategies, and there's no real good PKI that works across, and it seems like you'd still have a fragmented ecosystem.
Yeah, that's a great question. An issue. So what we wanted to do with Entoto was something that is not prescriptive in the way that people follow practices. So for example, we knew that it was a very bad idea to come over to the Debian community and say like, hey, by the way, throw away GPG and you need to use OpenSSL. But in contrast, you cannot do the same to, say, Microsoft, that are probably very invested in code signing. They have a big infrastructure to do this the right way. They have their own processes to ensure that everything's done to the letter in that sense. So we wanted to be a little bit agnostic on those particularities. And we're providing tooling to basically interface with those PKI solutions, to call it, and to call that group in a way. Entoto does allow you to say, well, this GPG key can be used for git commit signing, but this other PKCSV8 PAM can be used for signing a build. And in a way, it's relatively agnostic, and that's by design, because we want to be able to cover as much of the supply chain as possible. I don't think we'll see a trend. I bring this up a lot, but XKCD 927, I don't like. We know the number by memory. It's unfortunate that in this industry we'll see that a lot. People will just say, come and say like, actually, we're open BSD or FreeBSD, and we're going to use Signify. And it's like, well, okay, then that's another thing that we need to handle. But the trust assumptions are basically the same. It's a cryptographic primitive that is telling you that this thing comes from the right person. I don't know if that answered your question, all right?
Yeah, it seems like that's, I think you answered it by clarifying that is still an area to figure out. And I think supply chain is extra tough because these are things that cross organizational and community boundaries and everything. And each one of these organizations and communities comes up with their own PKI system, like you outlined.
Right.
And so kind of bootstrapping that layout file with the correct keys remains a challenge.
Right. And I think in that sense, I hope that in the future, some conversations around this will start to crystallize towards some more universal standards. But again, it really does sound like XKCD 927. Yeah.
I have a question for you. How do you attest? So this provides a storage for attesting like who can make certain changes to the repository or to parts of the infrastructure, right? So you already need to know the person before you can trust them, right? So isn't there like a catch-22 here, so that, and an external developer coming in and submitting like a pull request or a patch, we have no way of using this infrastructure to sort of attest the patches that are coming from them. Is that correct?
Yes and no. The way I phrase it, and I think it's a running joke in Entoto community, it's insecure turtles all the way down. Yes, you need to have a mechanism to bootstrap trust. But for example, in the example that I was bringing up with Maya's key, is you could use the same driving principles to say, well, somebody who wants to submit a pull request and they want to be authenticated in some way, they can go through this process. And again, it probably doesn't need to be like Greg and Linus signing your key, but it could be something like, well, register your key under this directory and make sure that you present some evidence that you commit to the best practices of the code, or something like this, which eventually should float into the infrastructure to mark somebody as enrolled in the system and allowed to create and submit attestations and code, say. Does that answer your question?
Yeah. So kind of like we talked about the key server, like if I have like a Hagrid key server that specifically exists for this purpose, if you want to submit something, please submit your public key to this key server, which does the email back and forth as a sort of a way of verifying that you own it.
Right, and it could be other like interesting things, such as you can look at Let's Encrypt in a way that it has a similar effect, right? It's you are following a small protocol that eventually gets you a like bootstrapped into the SSL ecosystem, to call it somehow. You now have a path all the way to the Let's Encrypt root CA, which could be encoded as an total layout. In fact, it would be a little it would be more work than you need to do with Let's Encrypt. But if you wanted to do something like that, you could do something like that.
Again, just to clarify, I saw some examples about kernel.org using it, but kernel.org is not using it. It's just an example, right?
Oh, yeah. It's all these last two things were an example. I know that, for example, the second one that I put forward, Let's Encrypt is not producing in-total attestations. I know Cubesec.io can produce in-total attestations. I know that Travis doesn't produce in-total attestations unless you do some backflipping to bootstrap an OS image inside of Travis that has in-total installed. And same goes for kernel.org. I think that's also a good segue to another aspect that I think it's a common question here. A lot of people say, well, how hard is in-total to use? And a lot of the times people think that it is installing in-total in the right place. But in fact, it is not installing in-total in the right place, but taking a good hard look at what your practices are and distilling that into an in-total layout. Because more often than not, people find it that they have no clue of all of the practices and how the process actually looks like. Yeah.
Yeah, if I may, it looks to me like the bigger problem is the where's my PKI. It's easy to it's easy to say, hey, everybody signed it. Well, are those the right keys and are those the right people? And this doesn't solve that problem, and that's in my mind the key. Pun not intended. The key problem. So once you have, I can't avoid it. But once you have that addressed, then you can use keys and this to help you. But you clearly also need to solve the how do I know that these are the right people problem for this to work out.
It does solve it to some extent. For example, with reproducible builds, you can you have a layout that's signed by Debian developers, and that layout inside contains the keys of trusted rebuilders. So you can trust attestations from the trusted rebuilders by the transitive property of where they trusted to rebuild by the Debian packager that created this layout. So in a way, yes, it's secure totals all the way down because you need to bootstrap the trust of the Debian ecosystem into your, say, apt transport for reproducible builds. But this dials back all the way to the question that Dan brought originally, which is all of these ecosystems are basically using their own PKI solution, and you need to somehow fit their mental model. In the Debian case, you have some developer keyrings, and you have I think it's a user share apt GNU-pg.d that has a bunch of pop-rings to trust. So yeah, for the supply chain abstraction layer, you can answer the question of whether somebody's trusted to produce an attestation for this. But do I trust this particular layout? It's a little bit more of a complicated question because it does need to match an existing PKI.
Gotcha. Thank you.
No problem.
All right. Yeah, thanks. Could you paste I just left a comment, but if you could paste a link to these slides in agenda doc, that would be awesome so we can refer back to them. That was really helpful for me.
Yeah, it feels like the word trust is doing a lot of work in that last conversation. I think that's kind of thing we've been discussing in comments the last couple of days, right? There's two sides of it. There's the side of it is strictly do we recognize this entity as the one that we already know about? But then there's the first part, which is how do we trust this thing to begin with? And we seem to be mixing the two kind of liberally.
Is it Mike Purcell from Red Hat who's writing a whole book on trust because the word means so many different things? I think it's him.
Yeah, it is. Yeah, it's like I trust my brother with my life, but you don't know my brother. That sort of thing.
Exactly.
Yeah.
Cool. Thank you, Santiago, for the presentation. So the next thing we had on the agenda, and I was just thinking during Santiago's presentation how we might think about some of these categories, is we'd started working on a threat models doc to help sort of frame what we do in this working group. Let me paste the link. Oh, no, that's Santiago's thing. Paste the link there. And for those of you that started leaving some comments, thank you. Gavin, I think you're in there a few places. So what I thought we could do, and I could share my screen, is sort of just, continue the discussion on, what are the actual threat models that we see along the supply chain? And then taking it one step further, what are folks in this room interested in tackling? We started with a developer identity piece, beginning that whole trust thing in the supply chain, but think that we can, think about other things along the supply chain and like how to group these together, and then come up with a plan. So let me see if I can. Is everyone able to see the threat models doc? Or should I share my screen? Okay, well, I'll share anyway.
I'm on there, okay.
Okay, cool. So let me just share anyway. All right, I haven't caught up on all the comments myself either. So we started to categorize all the ones that were listed at the bottom, and these are some of the categories that we came up with, which we can discuss here what people's thoughts are on them. I think there's some comments about there might be some overlap. The first one we pulled out was account hijacking, and then categorized a number of the threats underneath. And then
sorry, I still don't really understand the point of this exercise. So, a couple of things. One, there's already a doc that lays out a lot of the existing threats that is incredibly well researched and written. That was led by Michael Scavetta, published by the Identifying Threats Working Group. And I don't know why we have a different list that we're working from. And second of all, we can certainly prioritize these threats, but I don't understand under what scope we are prioritizing these threats for what purpose. Just, what we want to go work on is not necessarily the biggest issue in the community today.
So this is basically, when we started this first week, this is basically meant to cover scope. So instead of trying to cover scope in a more abstract sense, cover scope from the list of threat models pulled out of Michael Scavetta's doc. So, and then a couple other lists of threat models. So it's not supposed to meant to be like a novel publication on the threat models facing open source, just a way to figure out the scope of this working group and what threat models people are interested in actually attacking here.
Then maybe it would make sense to take that doc and actually scope it up by working group, if that's the goal.
I'm not quite sure I understand.
If the goal is to address specific threats in that doc, then in theory, we would cover all of the threats in that doc between different working groups.
I guess the point here is just to figure out which ones this working group is interested in. I'm not quite sure the suggestion, like maybe, are you saying we take this up a different level and then have some other group decide, like assign threat models to people?
I guess I'm wondering if we're a hammer looking for a nail, then this doesn't really make sense to me. I don't understand why we're working on it this way.
I think we're a whole bunch of people that came here to work together. So I guess we're just trying to figure out which topics everyone is interested in. Is that kind
Sure.
of what other people?
But I think a lot of those topics are covered in other groups. That's hence my confusion.
Maybe we can reference the ones that are then. So
Yeah, I think we could use this doc to reference those, because I've sat in a few of the other working groups now, and I don't think any are quite tackling some of the things that we're talking about here. So, but if they are, let's call that out, and then we can make sure that we're not duplicating work anywhere.
I think I agree with you. It might be a good process to start from the doc that happened in the Identifying Security Threats group. I think that might be a process that runs from that working group, though, and then we could use that at some point in the future to identify if there are new working groups that need to be available. I'm just thinking that that's kind of I wouldn't want to stop progress on what this group is doing to wait for that, though, because there are some of the threats that they've identified that this group has identified in their document. I don't believe those are covered by other groups. Does that make sense?
I'll kind of throw my 2 cents in here, having been slightly involved in that other group's publication of that document. So the way I'm kind of hearing from different people is that, if that is sort of the source of truth, the centralized repository, if you will, of the known threats that we want to track, it makes sense to work off of that. But at the same time, I don't think that doc is really set up for then identifying who's doing what. And it seems like this document, I think, is useful for this group to help brainstorm, correct me if I'm wrong, Kim, to figure out what this group is going to target. And then eventually, if we just have a plan going forward of how we're going to reconcile the two together, so that we say, okay, we're not duplicating, we're not redefining what's already in that document. Maybe we add to it and edit there, and then we just use this to kind of dictate what this group is going to focus on. And I don't think there's a whole lot of conflict there. I think maybe the concern is just making sure that we're a little bit more coordinated. So if we're just more intentional about saying that we're more coordinated and how we're going to sync between the two, does that sort of solve everybody's concerns?
That makes sense.
Cool.
Well, I guess
Okay.
we can do that
Go
one
ahead,
offline.
So back to the doc. Using this to help scope what this working group is going to do. There are some few areas that we're particularly interested in, which is why we started this to begin with. So yeah, I don't know if people want to like openly discuss some of these categories. If you want to sort of thumbs up in the document, do a +1 on the things that you're interested in. That would be some sort of signal to us. Otherwise, I'm not sure if we want to go around to each people and to everyone on the call and ask sort of what you're interested in, but some way to give us some signal that would be helpful.
How about we mark our names under? Yeah, I was going to say, why don't we mark our names under the heading of each one? Would that help?
Yeah, that would be awesome. Yeah. And then this is linked in the meeting notes today if you lose the link to it as well. And so, Gavin, did you want to bring up any of the comments that you had about sort of the categories that we picked?
Well, I guess even just asking people to go mark which ones they're interested in, right? Interested in what context? I mean, these are all problems, but I don't know if they're all problems within the bounds of what this working group was supposed to be. So I think we kind of need to have the sort of fundamental, what's the scope of and the desired output of this group of people getting together.
Or what we could do is see if there's some interest in them, okay? And then the ones that there's no interest, they can be knocked out. And then the ones where there is an interest, we can assess if they're a relevant fit for this group, or is it a case that another group should be looking at this? How would that work?
Yeah, I think that sounds. Well, go ahead, Kay.
Well,
Does that sound good to you, Gavin? Sorry, go ahead, Kay.
Well, so I think we have just 12 minutes left, and we have had some. I feel like we should maybe shift focus and talk about scope of the group. I know, it's a little hard because we're trying to say, okay, well, let's let people just say what they're interested in and let that drive scope. But I think we, just given our time frame and the sensitivity about this group, I think maybe we want to kind of come from the other direction, make sure we understand the concerns that have been brought up with the current scope, think about how to address those. But I want to address those kind of in a way that's broad, that leaves this group room to still, go forward and decide what actual work needs to be done. But let's try to, I think we really need to address the immediate concern, or we'll have people still frustrated about that. So would you mind if we shifted focus and talked about the name and scope of the group?
I think before we can do that, we still need to sort of come to agreement with what problem areas people are interested in solving. Like, you can't scope something until you understand what you're trying to do together. So, I mean, that's why we put this doc together as some way, a helpful thing to help frame our frame our thoughts around this. So, if no one's interested in complete supply chain integrity in this group, then it doesn't make sense to scope the working group to just that. So I really think we sort of need to go through this exercise before we get to all the details on what the working group is going to do.
That makes sense to me.
Yeah, like, this is meant to be kind of an open community, and like, I found you can't really assign work to people in this context. You're kind of just shepherding and figuring out what people are interested in and trying to get everyone together. If we want to come and say certain things are off limits or something like that, I think that's a different direction. But to really actually get anything done, we're gonna have to just see who wants to do stuff and what they want to do first.
Let me ask one question. So, there was a proposal to change the scope, I think, to supply chain integrity. Is that right?
Yeah, there's a PR that's open that's linked in the agenda where we've started working on some of the.
Are there concerns from anyone with that? Well, first, are there people, let's just ask, are people interested in that? I think the answer is probably yes. But I can go write my name on it. Are there others who are interested in that?
I think supply chain integrity and verification makes a lot of sense. We've talked about surfacing some of that metadata as part of the dashboard project, but we haven't talked about creating that metadata. So we certainly need to talk about how that would work. Mm-hmm. My qualms remain with the word identity, specifically developer identity. I'm fine with code identity, binary identity. All of those concepts make sense to me. But when we start to talk about developer identity in the context that we don't mean cryptographic keys, I think that is out of scope.
So the name aside, the name is one thing. Kind of tying back to the conversation we just talked about before, bootstrapping PKI, I guess that's kind of the piece of identity that we've identified as missing everywhere from all these presentations, and that's kind of the piece that I'm really interested in tackling here. Is, that aspect of it. If we can come up with a different name or something that makes people feel more comfortable, that's perfectly fine with me. But that's kind of the big aspect of scope here that I'm interested in tackling here.
I'm going to slightly disagree with you, because I think that you could certainly manage a key today, and you could have 5 years ago using Keybase IO. And the fact that people weren't signing things is a problem that we need to address at the same time that we address how to manage keys.
So I think could we agree? If we could sort of agree on one thing at a time. So could we agree on a scope that is supply chain integrity and, how did you say it, Maya? Supply chain integrity and
verification.
Would anyone be opposed to that? Does that rule out anything that people are interested in?
I'm certainly not opposed, but I still think it would be prudent to just establish who is interested in what. Does that constitute the name of the group that we decide on?
I would
I feel
like
it's a useful exercise still.
it is. I think we should.
Yeah.
I think we need to be more.
I mean, you call a table because it has a top and 4 legs, but you need to know what it has to constitute that it's a table. That's what I'm thinking.
Sure, we need to broaden the scope of this group, and we need to do it. We need to do it expeditiously. So we need.
Can you get it? I mean, there's a sense of urgency here that I'm getting that I don't really understand where it's coming from. If you could maybe help motivate that, it would help. But I feel like we're being rushed into deciding something that we're not really ready for.
So personally, I don't have urgency to define the scope of this group. I have urgency of getting rid of the words developer identity. If you want the fastest way to possibly exclude the most kernel developers you can and get them mad at the Linux Foundation, this is close to the top of the list of how I would do it.
I've heard concerns from a number of different groups.
Well, could we maybe decide? I think we could decide to drop developer now, and that still doesn't mean we've arrived on a name or a scope, but then at least we address that. I mean, would others be conducive to that?
Hold on, do you mean dropping developer identity, or you said just developer?
Just the word developer, the reference to the word developer.
It's the identity word that's more problematic.
No, I don't believe so. I mean, correct me if I'm wrong, it's more developer, the context that applies to identity.
If we say co-ed identity, like I said, I have no concerns. There is wording in the file that is being changed in the PR right now that talks about naming, like people's names, and developer identity. Those are the parts that I feel very uneasy about. Like I said, I don't have a need to rush towards a new scope. Obviously, I would love us to figure out what that is, and I understand that takes time. But just those words are concern me.
The term is loaded. You're worried about
yes. So I mean, the way I see this group is to explore the topic. It's not to make anything mandatory or enforce, or it's. But I can totally understand the connotations that are there. So I just think perhaps for now we can at least remove the word developer, okay? And then that doesn't mean we've arrived on a scope or a title for the group, but at least we can resolve that. And then we can look at the scope and see how that creates, we can then make our name from our scope. That's what I'm seeing.
Well, and I'm sure there's a bigger conversation to be had here, right? Because if we end up needing to identify developers, it doesn't matter that we've removed the phrase developer identity. People are smart and they're going to figure that out, and it's going to be a problem one way or another, right? So there's, I think, a bigger sort of broader issue of how to wrangle that issue, right?
Yeah, very much.
If you would consider having a broader scope, then you're not precluding discussions about developer identity. You're allowing discussions about other things. You're resolving the immediate concerns that people have with the name of the group, potentially creating problems, concerns from developers. And I've heard these concerns. I've had people, coming and talking with me about it. And, I understand that this is an area that we want, that does need addressed, but let's just reduce the concerns, and then we can go about, working through the process. And I think you can reduce the concerns. This is just my opinion or my recommendation, by broadening the scope. And if you broaden it to something like supply chain integrity and verification, you can, continue exactly, we can continue. I know when I'm very interested in this topic as well, but we can continue working through the details.
Can we call it supply chain attestation? Because that would cover all of those aspects. If we are testing something, we're talking about developer identity, but we don't specifically mention those words in the title.
That works.
I
tested earlier. We could do a doodle poll, with some different names of things in the document. I originally wrote, some we called it supply chain attestation, supply chain integrity. They're all kind of similar, and personally, I think any of those could work. We just pick one and then move to that, and then we can continue about our business.
Maybe this is what Mike was getting at, but I have no opinions on names. We can do whatever we want, makes people feel comfortable, but I worry that that's just pushing the problem off later, where if we do find out people are interested in solving some of these problems, like what Luke just pointed out, it's going to make certain organizations uncomfortable again. We can take that when it comes, but
let's do that, because at least we can, even if it pushes it down, that's okay. Let's resolve the current issue, and then we can still have that discussion, and but we can have it in a less loaded environment. We can have it with time at our leisure. We do. I mean, there is some pressure to get this settled, which is that we're working to announce what our working groups are, and so the longer we delay this, the longer it takes to get it through the TAC and get approval. So I really strongly suggest that we move forward on a name and a broader scope, and then we can continue the discussions. That's me.
I also wanted to add that, it's been 15 minutes. I don't think that if we continue bike shedding about a name and then we end up doing absolutely nothing, anybody will care about the name anyway.
I completely agree.
Yeah, I think that's true. I think my other concern is that, this group isn't working in a vacuum, right? The work stream was created with this specific intention in mind. Who has context on what that, right? What was the problem they were expecting this group to solve? They created this work stream.
It's been my experience that nobody's expecting anybody to do anything. You kind of show them a solution and they will take a look at it and say like, oh, this solves my problem. If we're doing nothing, then I don't know.
But there's a problem space in mind, right? Otherwise, it wouldn't exist.
Yeah, all I'm saying is I think we should consider the context of, well, we're starting, and people will probably see a PR publication and say like, oh, that's cool. And it takes a lot of building to have people concerned about your name. And,
circling back to the threat model thing, I actually recall, I think it was the first meeting when we first started talking about threat modeling and how it was going to sort of drive scoping here. There was only, I think there's like a sort of semantic conversation here, which again, like we don't need to bike shed and debate, but like there was only, I think, one threat model identified that actually required physical identity, sort of like tying back to a human in a name. And I think that was a threat around two people, like one person, one physical person having multiple identities in the system. And interestingly, I had noticed that threat did not even make it into this document. So, even if there's some form of identification in this system, I don't think we're implying even yet that is tying to a real human identity. It could be something more like Debian's doing around reputation. And really it's a technical mechanism that may make key management easier, right? So I think it is interesting to sort of scope this stuff. And there is a real issue here around privacy, but I don't know that, yeah.
Yeah,
I'm going to
I
have
think
to drop now. I'm just thinking we're on the hour, so
right.
So should we go forward with dropping a developer term? Okay. Everybody
there's a
outline
PR
their
open.
interest.
So just
Okay.
yeah.
And everybody put their interest so that we can just be sure that we're getting when we decide on a name or how we're going to make a name at the next meeting, we at least know the component parts that make that name make sense. Does that sound good?
Sounds good
to me.
Thanks, Luke.
Yeah.
Cool. Thank you, everyone.
I have to go. Thanks, everybody. Bye-bye.
Thank you.
See ya.
Have a good day.
Yeah, I got to drop as well.